Hi, folks, and thanks for joining today. My name is Ray Plosky. I'm the field CTO of HashiCorp. And with me today from F5 is G. G, why don't you introduce yourself?
Hi, my name is G Chow, and I'm a DevOps specialist for F5.
Great. Well, let's just jump right into it about how you can improve your defense posture with F5 and HashiCorp. So G, why don't you tell us a little bit about some of the industry trends that are going on today?
Yeah, so today is all about cloud operating models, so I don't have to tell the folks here that so growing customer demands and cloud efficiency gains are accelerating development of innovation in financial services. But at the same time, it exposes potential security vulnerabilities. And because sensitive financial data is so valued by bad actors, financial or services organizations, they really need to take precaution to ensure securing application development and deploying while supporting governance, risk, compliance management. Now, security has taken a heightened urgency for individual businesses as cyber criminals, unfortunately, are exploiting these times. They're exploiting the potential vulnerabilities during the COVID-19 pandemics. And financial services really have to find a balance.
Absolutely, right? So we see on a regular occasion, a consistent conversation, regardless of what vertical you might be in, and regardless where you might be in a digital transformation, around both the need to actually move from private data centers into a hybrid cloud, as well as a lot more challenges. I mean, we've all heard the news of around things such as solar winds and the parlor hacks of the world, where you're a lot more vulnerable with moving to this new paradigm shift of adopting the cloud, as well as making sure that you have a strong security profile.
Right. So the pandemic has also focused the attention on financial institutions and digital capabilities, and we recently put out a survey, and 46% responded, and these are banks globally, that they're bringing new digital capabilities in production. So it's among their top 3 priorities in the wake of COVID-19. So Ray, prior to the pandemic, it was already a long-term priority, but now it's kind of shifted and thrusted it into a short term as well.
Exactly, right? I mean, even your local mom and pop pizza parlor now has takeout and delivery online. Everyone's moving to digital. Even our investors see that this has accelerated the trend by 2 to 3 years at this point. And, you know, there's a lot of great benefits with going to cloud adoption. However, there's a lot of fundamental challenges and concerns as well. So what we've seen with surveys as well as Accenture, that not only does the cloud offer ease of use, but it's also expensive if you're not careful about optimizing your cloud costs. The idea around being able to push out into the cloud expands your perimeter and what your attack vector looks like. So cloud security is another area that's top of mind on a regular occasion. And then while we're moving to this more agile way of delivery, with moving from waterfall and ITIL into this world of DevOps and self-service, self-service can be very, very dangerous if you're not very careful. So the idea around cloud governance and having clean policies to allow your developers to move as quickly as possible to deliver their applications, but in a way that is tolerable for the risk profile of your organization. So I know that you did some surveys around financial services. G, why don't you tell us a little bit about that?
Yeah, so in financial services, as we mentioned, cyber criminals are seeking to compromise critical infrastructures and getting access to valuable data like account holders' personal identifiable information. So as more financial transactions take place online, bad actors, they're going to want to get to the stuff that they can monetize. And that's, they're going to be looking out for new vulnerabilities and exploits with increased sophistication in attacks. So in recent years, we've seen that the vast majority of security incidents in the financial sectors have fallen into 2 categories: brute force and credential stuffing attacks and distributed denial of service attacks, both which are trending upwards. Now, interesting enough, web attacks, malware, malicious attacks. Although they're still lingering, they've become less prevalent. And Ray, I think what we're seeing is that these bad actors, they're focusing on things that they can monetize, and it's more about kind of, you know, a business, unfortunately, for these bad guys. And it's less about, you know, kind of doing things like defacing websites and stuff like that.
No, I mean, the vast majority of these are uh, exploiting network, being able to get to your data sources, whether that's PII or profit and loss ledgers, exfilling the data and getting off that network as quickly as possible. So there's a lot of different techniques and best practices that both myself and G will walk through today on what you might want to consider with your enterprise in order to mitigate as many of these risks and threats as possible. And don't believe me or G, these numbers come from Cybersecurity Ventures Cybercrime Annual Report. They say about $6 trillion is what's the estimated losses in 2021 worldwide for enterprises. Satya Nadella put that number at, I think it was 1 trillion for 2021. Accenture put it at 5.9 trillion. Regardless, it's a very large number financially of what's going to be happening with this continued attacks against your properties in cyberspace. And out of the last 10 years, 20 companies have experienced massive data breaches that were over $1 million. About 90% of them use HashiCorp's Vault, which we'll get into a little bit of detail about what that is and why in the long run.
So let's talk about budgets within these financial services organizations for cybersecurity. So in December 2019, experts were predicting that in 2020, this is before the pandemic, that we would see a modest growth, about 8.7% in cybersecurity spending. So with the COVID-19 pandemic, it's no surprise that folks are looking at security budgets again. So instead, they're being slashed. So Gartner is actually saying that these are going to be revised, and now the estimate is a 2.4% growth in spending instead. So they're predicting that it's going to go down. And Ray, do you think that that's going to be the case? That the Gartner is right? It's going to come down?
I wouldn't say that Gartner knows everything and has a crystal ball. I think that there's a lot of spend in folks that are still investing in security and infrastructure today, as their businesses are primarily reliant upon the public clouds and being able to reach people in ways that they didn't have to in the traditional brick and mortar days. And now with the change and acceleration of digital transformation, that trend seems to be continuing even now during the pandemic. How about you, G?
Yeah, I think that you know, projects that are proposing, you know, leveraging clouds or remote technology will likely be approved, and then cybersecurity around those kind of formats will be in place. There'll definitely be, you know, some creative ways to cut in other areas, but I think there's opportunity here in organizations to leverage what we like to call a kind of an evolved application methodology, where you integrate security measures within the application rather than the application lifecycle rather than an afterthought. So we'll dive into that shortly.
So moving on from trends a little bit into some security considerations and architecture, G, why don't you tell us a little bit about the layer threat classes?
Yeah, so as you know, everyone wants to build the app as fast as possible, but that increases kind of this threat surface area. But really, there's kind of three main classes of threats. So the first class, if you can advance the slide, Ray, is software vulnerabilities. So obviously, as no software is perfect, but what the bad malicious actors are good at is sharing information when there is a vulnerability. So there are organizations like OWASP that kind of catalog and get the word out when these exploits of popular software are known. And but it's important to know that the first category is kind of, something that's baked into the way software is, that's within the web app technologies in general. And then the second class of threats is bots and wanted automations. So, we typically leverage automation in a good way, but malicious actors basically build a category of threats around the lowered cost of compute nowadays. So basically, they build a bunch of bots at scale. They build a bunch of DDoS attacks at scale that are deployed and pointed to your apps. And that's oftentimes used in conjunction with a vulnerability that they found, and they'll kind of use that automation to either weaken an application security or kind of bring it down. And the third and final category is a targeted attack, an advanced threat actor. So this is when the malicious actors are looking at your specific application and doing a reconnaissance, doing a profiling, and looking to bypass that specific app's security services. And then maybe they'll look at it and say, okay, I can see that they're using X, and then I'll develop an exploit around that for that app. Or they'll say, okay, I noticed that that specific app is using an exploit. So it's so this is really, looking, the bad actors looking at the app and then, building something around it to attack it.
Really interesting. I mean, we've seen tons of these stories out in the world, whether it's the Targets, the Cap Ones, the SolarWinds, the Parlors, and that's just within the last 2 years. I'm going to take it and change the perspective into a different lens to walk through what we see and what we see our customers dealing with as a typical challenge. So you have your app and you've scanned it and the source code for making sure that there's no known CVEs or exploits out there that are available. And you have to place it upon a server that's run somewhere, whether that's in your private data center or whether that's in the public cloud. And the typical approach requires you to make sure that you manage and maintain and patch those servers and those environments so that they are not stale, where these hackers might be able to penetrate into your given systems. And then furthermore, if it's anything more than a university computer science project, you're going to have to connect to some sort of data source and pass an ID and a password to a database that resides typically on another server. This all of a sudden makes your challenges or your vector that much larger. You have to share your credentials. That application typically drops logs into a Splunk or a Datadog or otherwise, as well as into application performance management systems. And oftentimes you will share your credentials or save them as a properties file into a source control system. So after folks typically try to access your customer information, their credit card or their PII or social security number, the second place they typically look are these secondary systems, the log files, to see if you actually spit out what that database password is, or if you checked it into a source control system. Problems get even further challenging once you take these applications and you start to carve them up into microservices to define and create systems of engagement that are really spiky and that can ephemerally spin up 1,000 instances of that cart microservice or of that product microservice and then tear them back down again. So you're not only dealing with the sprawl, but passing those credentials automatically and defining a policy of who can access what given systems, and also scale it out to hundreds of thousands of instances and then tear them back down again. And then what we've typically seen in the past is that we try to build a traditional data center paradigm where we have a strong perimeter with a very well-controlled ingress and egress, where we put things such as a SIM and a WAF and a load balancer and a firewall on the outside. But in effect, the network is still pretty grossly segmented into areas such as an environment, a prod environment, a stage environment, development environment, where you still have some challenges. I mean, we'll talk a little bit about how you can mitigate that with VPC clouds and the like. But the fact is your blast radius is still very large. And then once you actually add in things such as your public clouds, you have quite a bit area of low trust, since you don't necessarily trust their networks or your own because you don't necessarily own what is running on AWS or Azure or SaaS. So it becomes quite a bit of a challenge around, do you have a high trust network anymore? Do you have expense from indirection? Do you have multiple areas of ingress and egress from these multiple cloud providers, or from bring your own device, or the VPNs that people actually bring into these given systems? And then what about the self-service automation that does occur with DevOps? Are you allowing your app dev folks to be able to push into a production environment without any sets of controls? And this is what a lot of folks seem to be challenged with when they're building out their environments, and what we keep in mind here at HashiCorp on ways that you might be able to address that. But what if I treated my servers as immutable architecture, and I used infrastructure as code, where I could actually define policies or guardrails around things cannot hit the public internet without having someone review it, or the fact that we might want to be able to tag particular portions of a given app so that we know all the given pieces within the multiple layers of a given stack, and be able to define immutable servers for our architecture to go upon. This allows us to make sure that we can maintain and manage our static and stale environments at scale, whether it's 1, 2, or 20,000 on day 0, day 1, or day n. And it allows us to be able to define policies for the 90-10% rule, where 90% of the work that's occurring is mundane, and we can allow that to be automated and reduce the toil for our ops teams to really focus on those more challenging problems. And then what if I was able to not trust that given network, and my users could pass in who their credentials are, get back a temporary token for that database, so that service can then go and access it at any given time. Vault allows us to make sure that we can have an agent that allows us to be able to interact to find out if I have the privileges as the cart microservice to go and talk to that given database at any given point in time, and also be able to rotate that password on a regular occasion, whether it's every 1 minute, 5 minutes, or 10 minutes, or every hour, whatever you need in order to make sure that you can mitigate as much risk of having old or stale passwords that get pushed out into those logs or performance monitor systems on a regular occasion. This allows us to be able to get rid of the shared creds, as well as a lot of the secret sprawl, and also allows us to have that policy, as we discussed. And growing further with the adoption of microservices, you'll find that you'll have tens of thousands of services in time. If you can be able to provide a service mesh, which allows us to be able to connect between the various services via mutual TLS, it allows us to make sure that we can address quite a few bit more of those given concerns that are discussed, such as having very fine-grained controls or intentions between many services of what can talk to exactly what else. Also allows us to be able to implement the zero trust model, and also allows us to have multiple ingresses, but really doesn't matter. As long as your services are all working through this controlled dial tone of a service mesh, you're able to mitigate quite a few of those given risks. And finally, schedulers allow our devs teams to be able to deploy their jobs or infrastructure as code via a north-south type of API, where the systems that can then go and evaluate against given rules and policies, find out where on the distributed compute grid, whether it's on your on-premise or in the clouds, what compute is available, what is being patched and upgraded, to be able to run any given job or container at any given time, to avoid the Wild West type of DevOps that we've seen challenge quite a few organizations when it comes to their risk profiles. So in a nutshell, I know this is a pretty big eye chart, but there's a whole lot of different pieces that allow us to address many of the given concerns when it comes to identifying and upgrading your given profiles security-wise. G, I think that you wanted to be able to put a different spin on it, a little bit more around the build as well as the operations portion. So why don't you take us through a little bit of that?
So let's talk about in previous generations how this was done. So in previous generation, there wasn't so much a concept of leaving controls and policy tweaks in the same cadence and methodology of an app build lifecycle. How it used to look is that you'd have a code build process where the developers build the code, and then they would do a static application security testing. We click to the next one, Ray. And there may be some other tools that are controlled by dev, but it really isn't until they deploy it to production, and that's where quote unquote network security controls are placed in prod and owned by security. And then there's a set of tools that are owned by a different group. That production level is where if there's a failed test or a security catches something that is caught as a vulnerability or a security something that's not up to the standard, it gets sent back as a quote unquote failed test. So treat it as a failed use case rather than kind of iterated really quickly. So it goes back to the beginning, to the developers, and we start the software development lifecycle again. So again, deploy, operate, and then monitor. Now, security, if security control causes the app to fail in production, then it's treated as a misconfiguration. And this also leads to finger pointing. So that we definitely want to avoid that. So with a new paradigm of an evolved application methodology, what you want to do is shift security controls left. So the benefit of that is that you're sharing the responsibility of security throughout the process, throughout the software development lifecycle. And what this does is it gives you tighter loops rather than having two giant categories of development, finishes the development, and then throws it over to tests, and that's much less efficient than if you had a code level static analysis done at the developer level, and then you'd have kind of a iterative, you have a per app right in the build phase, and have a WAF there, and you can have developer test implications of that application build WAF, and then you can do your dynamic testing in an actual test environment rather than pushing it all the way to production. So if you're shifting these models left, that'll give you tighter loops, and the benefit of that is that we're going to find these problems earlier in the pipeline, which is quicker and cheaper because they can be addressed. So let's take a look at this shift left paradigm and zoom out a little bit, and how can you apply that in enterprise cloud architecture? So we developed a pattern called security cloud architecture, and this pattern features a common security VNet. And this is really your entry point or edge where your users come in. And what we're doing was at this front door, we're also blocking the traffic that we don't want inside our environment. So this is kind of the front door where you place your baseline policy to protect that front door. So this common VNet or security VNet, if you will, it's also where your shared services of all your cloud or multi-cloud apps can use. So for example, you have SSLO inspection in this zone, or you have your identity solution sitting here. So that's where the blue is. Now, moving to the next tier is the four boxes to the right, and each of those boxes are specific applications. So in each virtual network application is you'd have a NGINX App Protect that's protecting that individual app. So for your app, you may be doing something very specific, and for example, you may have a container ingress services protecting your container-based app, and you want to have a policy that's protecting in a manner that's specific to that app. So you can have a policy that correlates to that app in addition to the common or baseline policy sitting in your security VNet in that big blue area. So this is what's neat about this paradigm or this pattern is that the security VNet policy is likely going to be changing a lot less than your application area, because you're not iterating it and kind of catering that policy to how you build your app. So this also is nice because you kind of have a separation of controls. You can have app teams have more direct control over what gets in and out of the policy. and at the speed that they need. So the other option, if you look at the top where it says F5 CS, that is F5 Cloud Services. So for folks who want a simplified security solution, one where you don't have to kind of manage the infrastructure at all, and a totally SaaS-based model, you can have a cloud services-based WAF that can be your per app way to protect your application. So that kind of simplifies that, and that's also an option that can be consumed either in a data center or in a public cloud. There's really three major ways you can consume and manage the WAF, and they all have their kind of pros and cons. So the first option is a self-managed one. So the method that has the most granular control. So this is if you manage and deploy your the WAF product within your infrastructure. That is gives you kind of all the configuration rules for you to manage yourself. And we talked about F5 Cloud Services. So as a service is the second model. And at F5, we also have a WAF that gives you a simplified, centralized way to manage things because you really don't have to own the infrastructure. However, you can still leverage the same shift left model. And then lastly, managed service.
Really slick. So either if I want full control, I can do it myself. If I want to make sure that it's as a service where I let you handle all of the configs and standing it up, or even further to make sure that your experts can actually create rules and tune it so that that WAF is as optimal as possible from the best practices that F5 sees across all the companies. Got a whole lot of options here. The same thing goes actually with Vault. Vault, you can actually run it as a self-service, or you can run it as a service provided via HashiCorp with some of the best secrets management and encryption as a service best practices around. The three major cases for Vault, which we'll talk to really quickly, include the ability to centrally store your secrets and protect them and have role-based access control. The ability to rotate what types of data encryption algorithms so that your app dev teams don't need to look at Stack Overflow's most popular response on how do I encrypt and then use it within all of your applications. Because guess what, those hackers are looking at the same way to be able to do that too. So if you want to rotate from AES 256 to something else, you're able to do so and version it in ways so that your app dev teams don't really need to worry about it. It makes it a whole lot less. So the idea of making sure that you can crypto anchor so folks can't exfil information across or out of your given systems, and the ability to do so across all of your various clouds or your on-prem systems in a clean and consistent fashion, providing ways so that you can have tokens that are one-time use, or can expire in 10 minutes, whatever you need for your various different types of policies in order to ensure that even if you do have a breach, it's minimal and your exposure is much shorter than having a 5-month-old password. I know that we talked a lot of high level around some of the concepts and a lot of the industry trends, but G and I have committed to making sure that you can put your hands on the keyboard and understand these technologies and how they fit together in a clean and consistent manner via a workshop. So we'll walk through Vault as well as F5's web application framework, or firewall rather, and have a whole lot of fun within the next month. So what I'm going to ask is that we will be following up with an email to everyone who has attended. If you're interested, please sign up and we'll walk through step by step how these things can be stood up and provisioned, configured, and pushed out into a production environment. Okay, I think we are unmuted and live, G. Thanks for taking the time, everyone, for listening to the conversation around security postures using F5 and HashiCorp technologies. Why don't you tell us a little bit more about our hands-on lab and what we're looking to be able to achieve, Gene?
Sure. So the participants here today will get an email, and it'll be a link to a workshop where you can actually try out the concepts with in a lab. So we put together a lab that's a combination of F5 NGINX technology, specifically what we call NGINX App Protect, in a container-based environment. It's going to demonstrate the concept of DevSecOps, or the shift left methodology that we just talked about. And so it'll introduce the concept of, hey, you can stand up your infrastructure with ephemeral IAC technologies like Terraform, which goes really well with super lightweight ADC and WAF like NGINX App Protect. And then you can configure as well as set security policies in a lightweight WAF like NGINX App Protect. So that's what you'll walk through in a container environment. We're pretty excited about it. So I think folks will like it.
Yeah, it'd be great to get some hands-on keyboard, but with this format, it's a little difficult to have with the folks in the audience. But we're hoping that many of you can join and participate and really get your hands dirty with some of the technologies, whether that's Vault or Terraform, provisioning it out to Azure. Now, everyone, we have a question icon in the top right-hand corner. So if you do have any questions, please don't be shy. But I guess as a starter question, why don't you tell me a little bit about what you've seen is the best way to shift left with your security model, and what kind of controls and teams you have to keep it top of mind.
Yeah, I talked to a lot of customers, especially in financial services, who who kind of have quote unquote legacy model of development lifecycle, and that really just means that it's not yet integrated with kind of this concept of integrating security policies as part of the build cycle. So I would say, after you've kind of done an inventory of what kind of apps that you want to, work together with the dev team and the security team to kind of have this unified goal of iterating earlier and together. I think what's good is if those teams establish kind of, their short list of goals. So a lot of times you're on different pages of what you're trying to achieve. So I think the first thing is, picking the right apps and then together identifying goals for that specific apps. And that often involves kind of doing, a profile of the app, what's are unique for that specific app and what you have to protect or what kind of special thing it needs. But we know that if you're going to the cloud, definitely one of the imperatives is to move faster. So that's kind of, driving the change. So it's definitely something top of mind for folks.
Gotcha. And from the HashiCorp side, it's pretty consistent regardless of what vertical you're in, of how we see people evolve their security postures. A lot of times, one of the very first milestones is the basics, what you need to be this tall in order to ride this ride, so to speak. Where a lot of that's around secrets management and being able to centralize that into a single area. And we see a lot of folks using Vault to be able to do that around many of their different layers. And secrets are not just usernames and passwords. They're your API tokens, they're your TLS certificates. There's a bunch of materials on very different layers of the stack that you can start to slowly move outside of your spreadsheets or the PEM files in your home directory or your source control and into a centralized area and apply policies so that only those people who are able to or need that particular secret have access to it and it can be logged and audited for later on for global risk and compliance. After that, you can start to slowly get to an area around shared services. And there's some really good talks about that of folks that have gone through that journey over 6 months to 18 months to 2 years. One's by Adobe, talking about how they've operationalized their secrets management. Another from HashiCorp is from ABN AMRO, a bank out of Amsterdam that talks about what given layers and what they kept at top of mind for being able to create those secrets and then be able to rotate them and have better hygiene. And then after you get through shared services, you get to some more sophisticated types of abilities, such as encryption as a service, or being able to tokenize or format data from third-party apps in a much, much more sanitary and clean version to reduce the amount of risk that you might have. So there's a lot of different great talks of how people have done it out there above and beyond just the theories that I encourage anybody on this call to be able to go out and take a look at. Now, there's some questions that are popping up in the Q&A. There's one regarding NGINX. Do you mind talking a little bit about Volterra and how it might fit into a big picture with NGINX? You're on mute.
Oh. So So yeah, so Volterra is a recently announced acquisition, which isn't finalized, so I won't spend too much time talking about details. But we're excited about fitting that into our portfolio. That obviously introduces different use cases, especially for edge compute. So definitely look out for more news coming soon for that. I want to shift to a different question, which is, I think it's a pretty good one. Do you envision, so the question is, do you envision app developers becoming more responsible for embedding security policies and governance, or utilizing the core policies and governance established by SecOps or security teams? So yeah, that's a really interesting question. I think if you recall in the concept of secure cloud architecture, which is kind of like F5's take on how you can segregate that. That's one model which I've seen customers do. So it's kind of a concept of having two tiers. The focus of your edge coming in, your ingress, you would have in the cloud, you'd have a VNet that would establish kind of your baseline policy. So a lot of times we see, quote unquote, SecOps or the central security teams maintain control over that and have kind of that baseline policy. They're watching the front door of your more complex environment that houses many different apps. So that next, lower tier environment or app tier is often where the app teams know best about what policies and security configs are needed. So a lot of times we see that as a shared responsibility. So that's a model that we're seeing, but I think that's a good question. I think we're starting to see, kind of this more collaboration. Ray, do you agree?
Yeah, there is the 80-20 rule when it comes to being more responsible. Absolutely need to become more responsible for their secrets management, not checking their keys and making sure that they don't pass around secrets via Slack or what have you. Database passwords and dev, that's not a huge deal. But once you get to further environments, that becomes a pretty risky proposition in the long run. So being able to delegate a lot of this out via API, you're going to find that you'll have a centralized control plane to be able to put policies in place saying that, the app dev folks should be able to hit the app server, but not the database. DBAs, likewise. You can get away from the idea around level 4 type of controls, whether that's IP and ports to the idea of identity for a lot of your security. It is a paradigm shift. But you think about it, all of these new systems that are systems of engagement that spin up thousands of instances ephemerally and then collapse them back down, you need to more use identity versus IP to be able to control that regardless. So it's kind of taking that same shift and moving it even further left into the food chain, I guess is the best way to put it.
Right. And it's not only about kind of moving fast in the cloud model. It's also about the concept of limiting the blast radius. We talked about kind of the 3 different types of cybersecurity threats. So, that really, if a bad guy is able to compromise one aspect of it, something like Vault can kind of isolate, your secrets. If they in fact do compromise one aspect, you're still protecting others. So for app teams to have a security-minded mindset and put that into their own policies in conjunction with SecOps, so that's the model that we're encouraging.
I mean, the joke around HashiCorp is that PKI certificates expire one day after the tenure of an average employee, because it's hard, it's difficult to be able to do a lot of the rotations. But the more often you can actually start to centralize this, the more often you can have better security practices, rotate those credentials on a regular occasion, whether they happen to be passwords or keys or what have you, so that when they do get pushed out to your logs and your Splunk or what have you, they expire pretty quickly, kind of like your milk, as opposed to staying around for 2 to 3 years, where we've seen a lot of exploits with old credentials from ex-employees who were bad actors. There's another couple of questions I think we can answer with 2 birds with 1 stone. How do we sign up for the workshop? And are there any Azure-specific parts to this workshop demo? I understand that we'll have a similar setup on other cloud providers as well. So how do we sign up? I'll throw the link into the announcement section of here, but it's events.hashicorp.com/workshops. It's not up there quite yet, but we will be following up with an email with those details. as well as far as Azure, yes, the lab is specific on Azure at this point in time. We're able to create the resource groups and provision it up via Terraform to be able to go through all the cool stuff that G was talking about. You want to have more color or context, please do.
Oh, and actually, we probably killed 3 birds. There's another question is asking. This is a person who's self-proclaimed newbie, and they're trying to achieve DevOps solutions. So I would say this lab is a good way to ramp up in your skill set, because what we'll do is we'll have a lab guide and not just send you on a repo. The lab guide is basically step-by-step on how to kind of achieve different use cases. So I would say check that out, as well as the other workshops that are in that system.
Yeah, especially with the HashiCorp, there's a learn.hashicorp.com that lets folks get their hands a little bit dirty with some of the basics of both Terraform and Vault. So feel free to go take a look. So, G, we have about 5 minutes left. I guess it's called for any last comments or any questions before we thank you all for your time and attention. And if you don't be shy about reaching out to us.
Yeah, I just want to say thank you, HashiCorp, and thanks, Ray, for inviting us. We view HashiCorp as a trusted partner, and definitely some of our more cloud focus, as well as data center focused customers, rely on the combination of HashiCorp products as well as F5 products. So I'm glad we got to talk about kind of the changing landscape of cybersecurity.
Last opportunity for anyone to ask any questions or provide comments. Well, thank you so much, G. It's been fun to collaborate on this. Thanks so much, everyone. And we I guess we're gonna do.
I do. Bye-bye. Thank you.